All right, so we are going to start today's session. Actually, this is a re-recording, more condensed about the things that we did in the third session. We will be using, this is the second part, actually, and we will be coding DALL-E. That I explained, DALL-E is this model from OpenAI, and we will be using the code maintained by a group of people that actually is quite cool, but you can find it here at the GitHub from Afiaka87. He has like a lot of resources, so we are going to reproduce that in order to use DALL-E. So I'm going to put the link to that repo because yeah, like all the credits are to him, and because he's working with another GitHub repo that is the Lucid Brains that put everything out there. Probably I will put an extra session. So for example, this video is going to be about like generating results. I'm going to do a third video training DALL-E, and probably there will be a fourth video about using CogView. That is like one of the last ones, but that will be another bonus. So let's start. The code is not long at all. So the first thing is always to configure. Just let me close a couple of things that I have here. We are going to rename this. This is DALL-E. Generating images. Actually, this is DF 2021, session series 3, part 2. Again, if you want to try, for example, if you look at the part 1 of this session, session 3, you can try like because what we're going to input here are texts. Is text basically. You can try, for example, like generating new text with GPT-NEO and then input that or fitting that text here to get like interesting results. So let's do this let's do a couple of imports from Python. That display import clear output. We're doing this because we don't want to have like all the garbage that shows you that you're downloading stuff. So you want to see your yeah, you call it like a little bit clean. Let's do a couple of more things. Let's, of course, NVIDIA SMI. We are going to do pip install we can do, yeah, we can actually do use the git from github.com, Afiaka87 git. If you want to install another line, you can install what else? Transformers, taming transformers, sorry. I will show you in a second what that is. Want to do pip install DALL-E PyTorch. Again, we're actually, I always put this here. This is the step 1. Install dependencies. PAP install PyTorch. We want to install tokenizers. What else do we want to do? We want to do PAP install FTFY, PAP install regex, regular expressions, PAP install TQDM. We want to clone the DALL-E pre-train, so we want to do the git clone HTTPS slash again from Afiaka87. Amazing that this is an open source resource for everybody. DALL-E PyTorch, big shout out to him because I mean it's great. And that git. We want to install also PIP install one weights and biases, 1B actually. Because some models are hosted there. We want to do cd DALL-E PyTorch. Actually, I want to do one more thing before that. Actually, we can do it. We want to do it now. Before this, actually, we're going to do one thing. We are going to clone as well. Git clone. We are going to clone the official repo that is from Lucid Rains. See, or Lucid Rains. I don't know how to pronounce it. It's okay. PyTorch. I think that's okay. We're doing the pre-train, and also we want to install AP, install deep speed. All right. And we want to do also like clear output. If everything is fine. So once we finish that, we can print, for example, good. Move to the next step. I'm just going to execute this to see that everything is okay. Okay, it gave me an error, so let me stop this. Let me see notebook settings. Oh, okay. Remember to put the callf in GPU mode, and in this case, I'm going to use high RAM. I'm going to save it. Now it's connecting. So now should not give me, yeah. So you see now it's not giving me the error about that. It gave me an error because probably I have a typo on the here. Oh yes, this I have a typo here. So I'm going to run this again. Always check for that. And also you can see that here you'll start seeing some things added to your files. So yeah, so for example, DALL-E, PyTorch, we have now we will have all the files necessary to use it and to generate images. So far, I don't see previously imported by this runtime. Okay, all good. But let me run it again because of what I was saying. There was a error here. So we should see everything okay. In a couple of seconds. All right, so everything is good. Now we can move to the next step. The next step, step 2, will be basically choose the model. We can choose a model. We will download, again, some models that are maintained by the community that is into like this DALL-E thing. If you have been following like Digital Futures, you can see that you probably know that Theodoros Galanos is one of the ones like more focused in architecture, contributing with models. So we will use those models because they are there, and so it's useful. So pick a model, basically pick a model. To do that, we will write the code. We will enter cd content. Basically, this is we will enter this folder here. We already have, we will import 1B, weights and biases, because probably we will use it. Actually, we can do one thing here. We're going to use this line to format everything. At a specific height of the frame that we are going to use. And here, we can do the following things. Just bear with me a little bit. Okay, we're gonna have like a couple of options here. So we're gonna say, for example, like URL. We're gonna put a couple of addresses here. You can always like download this model by yourself. These are hosted at Mega. So probably we'll need to do one more thing if we're using a model that is hosted on Mega. But for now, I think we're cool. So, I mean, we can make this like more interactive, like a drop-down menu. That's fine. I'm just gonna, you can get creative with that. I'm just gonna copy this and put like different URLs to the models that are out there. URL. You can uncomment, and that's fine. So what else? So let me see the other models that we have. And there is one here from the weight and biases that apparently, according to them, I think this is a model trained by Theodoros Galanos that they said is like recommended. Let's see. I mean, I haven't used these models yet, so let's see. So what we are going to say here, basically we want to use, you can use like any of these models. Let me check. So for example, this is an old model, also trained by Roland Bolt, I think is the name. Rob Van Bolt. This one is more general outputs. And this one is the old Coco model. This was by Afiaka 87. So now we can say if I'm a little bit dyslexic nowadays. So if HTTPS mega.nc in URL, remember that we are commenting this guy. So we're going to do, you can replace whatever you want here. In URL, we're going to say that yeah, we will have to do one extra step. So let's see how it goes. So we will say like content, because we don't have that. We need to install. Actually, let's do one more thing here. Put another line of code. Just bear with me for a little bit. So here we might want to like download and set up mega down, because some models are hosted in mega. So you need to basically execute a batch file. So it's a little bit tricky. So let's do this. So basically with this, we are getting the megadown.sh file, and with chmod 755, we are just changing the permissions so we can execute the file. Otherwise, we're going to have like permission denied. So apparently it's here. It's here. So then we have to basically like call this file. So we're good with that. Actually, we can do it like clear output in case we don't want to see that. But that's fine. So now that we have this, we can say that if we find that, we can actually, let me put this directly here in this. I'm going to put it here. So content, the mega down basically is in the content folder. You can always like copy the path, of course. So let me do that. And we can say URL and DALL-E. So basically, we're gonna download. And sorry, and this is a PT, not DALL-E checkpoint.pt. We will download the model and we will call it DALL-E PT. So let's see if this works later. Let's finish writing this because we need to do if basically elif what we can say, else. Let's just try with two models. People start like texting me. So else, basically, we're gonna say whatever model that we have. There's one here, for example, this one, the old Coco model, probably. We need to do something, but whatever. We're just gonna say that whatever, if we don't have a model that is hosted on Mega, what you can do also, I mean, just like get this address and get this address and just like download the model and host it on a Dropbox. It's gonna be easier. Or Google Drive, and then just put like the address. So here we're gonna say that URL so always forget if this is an O or a 0. Sorry, it's DALL-E checkpoints. Oh, it's a minus O. Oof. Oof. DALL-E checkpoints.pt. So basically, it will do the same thing. It will download the whatever file according to the URL that you're giving it, and it will basically like rename it. Let's see if this works. So eval.js is not defined. Oh, yeah, I forgot to do something here. Probably we don't need these lines, but basically you need to import eval.js. Okay, we are downloading this model here. So yeah, we see that this is working. I will try to run this with, for example, the URL. I'm just gonna do this. That's fine. I mean, in case you want to use the Mega to just change the URL to the one that we have. So let's finish this part. So now that we have this, we can clear output. And here we can make a new folder, make dir and -p, and we can say that cache DALL-E. We can just say here like get, and here we need to download like the checkpoints for the BQ-GAN. Because we're going to use that, the BQ-GAN. Need to also get the YAML file, and also this file over here, the BB, the variety.bb. So we need to download these 3 files. And once we have that, we want to copy those files to the folder that we created. So we're going to say cp for copy. We're going to take this guy here. And this will go to this folder right here. And we're going to do the same thing with the other file. So just let me put this, and we change this for the YAML file here. Oh, sorry, let's change the wrong one. So once we have that, we can also, I mean, if we want, we can, I will clear the output actually in the end. So print all good. Now we can generate images. So now that we have this, let's see if we have everything okay. We don't have like any typo or whatever. It's downloading the file again. So we should be good to go. So it's downloading. Just see like this file. It's going to take a while, so I'm going to pause the recording. So you see that now it's all downloaded. So now we're good to go. So we have the file here, the DALL-E. We have the other files also copied. I don't think we had like any problem with that. So, oh yeah, now I see all the files. These are all the files that we need, so we're good. So let's do the final step for this part. And the final step is actually just like step 3, if I'm correct. You see that the code is not, this is just a bunch of like downloading stuff and just like pointing to the right direction. These are way too like complicated models to start like coding by yourself. So again, like big thanks to the people that are doing this, because it's good to know that it can be used. So now we can generate images from a text prompt. And how to do that? We can start by doing some imports. Import OS, import glob, import matplotlib, DLT. This is like the typical thing. Import matplotlib that image as nping, and we can import random. So now we will say that our checkpoint will be, and here we can just copy the path of our checkpoint. And now we can, for example, input a text. You can do this again, like interactive. But so I'm going to show you how. So for example, we can say sunset at the mountains. And I will show you a trick later that probably will get us like better results. So we can do this thing like pound and @, and we can say rm. And here we can just say type. And this is a string. So you see that now we have like a place to actually put whatever we want. So here we can say sunset at the beach, people dancing, for example, like whatever, and this will change here. Now we need to generate we can select num images. This can also be a parameter. So, but we're just gonna leave it like another type of parameter, like interactive, and put it here. So we're gonna say like num images, like 8, or you can put like 16 if you want. Batch size is 8. And here we can say the following thing. We can say like the text cleaned. I'm just gonna use exactly the code that from the Afiaca GitHub. We're going to replace like empty spaces and also the underscore. We're gonna create a folder, and that folder will be, we will create a string. So we will format a string. That will be content, and here we'll put like outputs, and here this will be text cleaned. So when you have the curly brackets and if you put the parameter, basically that will be in the string. What else? We can do now. Let's we can just like create a Python, and here we can go to DALL-E folder, generate, copy path. Basically, we're executing this file, and we need to DALL-E path. We need to put the arguments. So this will be our checkpoint. We need to, when using the taming transformers, we're using taming. And we are going to add also here the text that we're putting. We need to put also the number of images. So num images equal to images. We need to specify the batch size equal to batch size, and also the output directory, and this will be the basically the folder. So we can say the folder, and I think that's it. Let's see if this. Oh, actually, we need to. We can add one more thing here. Let's execute this. So let's execute this. Hopefully, we don't have like any typos. Oh, gave me an error. Images. Let me go again. Do I have typo? Are required text. Oh, text. Of course, I have typos. Equals to text. Let's say now. Let's see now. Yeah, apparently now this should work. Let's wait for it to do whatever it has to do. Yeah, apparently it's working. You see that's generating images. So the images, you will see the results you'll see a couple of things. We should see the images soon. Actually, we're not going to see the images because, but I mean, it's generating the stuff. Yes, created. Outputs. So you see, it's generating images from that. I don't know how these are like people at a beach or something like that, but that's fine. Let's just change the prompt. We know that this is working. We're just gonna complete the code so we can also like visualize everything. So let's do one more thing. We're gonna say like for img path and glob f, and here we're gonna put the output deer. So actually, oh wait, I need to do a couple of things first. Let's not rush. So here's just like display images. This is generate images. Here we're gonna say that if inline, it's the magic line. We're gonna say like final equal to text cleaned, and now we can say that we are repeating this, but that's fine. We're just gonna repeat this line here, text clean, and we will say that the out deer is equal to, let's format the string, and that will be the outputs. This will be this copy path, like this, and this will be equal to text. Sorry, inside the curly brackets will be text cleaned, and this will be equal to final. So every time that you execute this, it will create a new directory with the name of the prompt that you input here. And now we'll create an empty array that will contain the path for the images. So here we're going to say that for all the image paths that we will find in the output directory, and this is asterisk.jpg, because the images are in JPG format. We are going to see if I'm correct. Yeah, out there. We will say that images, append the images, and we will append the ing, im read, and here we will pass the image path, ing path. And now we will say, so in basically we're adding the images to that list, and now we're going to say plt.figure. This is like typical. Actually, I'm not gonna bother like going through the code. This is just like very standard matplotlib thing to basically generate. We don't have this, so to generate a grid displaying the images. So after that, we can say again clear output. Actually, we're gonna do the clear output here. So let's change the text prompt, for example, a dog fighting with another dog. And I read somewhere that if you put like Unreal Engine, so actually no, let's do the same thing. Just let me go back. I was reading that if you sunset at the beach, people dancing, Unreal Engine. If you do this, if you put Unreal Engine, you get like better quality images. I don't know. Let's just try. So if we don't have any errors, this should produce our images. I'm going to pause the video and go back. Okay, so it generated the images, and I have to say that if you put Unreal Engine, you get like better images, and that is surprising. So it has like more defined edges. Of course, this look nothing like people at a beach or something like that, but you see that images are like, this is the image without Unreal Engine prompt, and these are with Unreal Engine. So let's compare another one. This is without Unreal Engine, and this is with Unreal Engine. Yeah, way sharper. For example, this is without, this is with, yeah, way sharper. So let's do one more thing. Let me close this. So let's change, for example, red car at the gas station. Let's do that. Let's see what we get. Actually, this works like quite well. Not too slow. So let's wait for a couple of seconds, and after this, we'll just call it a day. It's generating the images, and we will finish this session. A red car at the gas station. Yeah, I don't see red cars, but that's fine. Now let's see if we have like Unreal Engine, so we can compare the results. But as you can see, like in the next part, I will teach you how to train this. Probably this video will be released like a little bit like later, and probably like tomorrow, and we can, I mean, so you can play with your own data. So let's refresh this. We have a red car at the gas station. Yeah, I don't see red cars, but the images are, this is the original. Yeah, like the colors, the contrast, when you put like Unreal Engine is like way better. Let's try one more time. A brown bird. A green chair in a white room. Let's see. No green chairs. Yeah, probably you need to play with like other models, but that's fine. play with this, and yeah, let me know about the results. You can always try with the other models to see what you get. I will complete this code with a couple of more things, and I will share with you. Probably will put the link in the description, like, yeah, all the information. If not, just follow the video and you'll be fine. So thank you.